Well, I think this is it. I think I'm live. I'm live on the YouTube. Alright, well, put the link on Twitter, so I guess here we go. I'm gonna start tonight by trying to do up a simple schematic. I'm trying to build a multimeter and put some Nixie tubes on the front of it because I've got some Nixie tubes lying around. So I posted a couple of things on the blog about this previously, but most of it's been pretty dry design side kind of things about how to, do an input stage design for a multimeter. And I've gotten to the point now where I actually want to start pulling in parts and doing a schematic layout. So here goes. I'm going to start with the resistor ladder because that's the part that I've specified already, and I've got some parts picked out. Looks like Mark's online. Hi, Mark. So I'm going to start by setting up a couple of components in a schematic library. So I'm using Circuit Studio because it's Altium's sort of mid-range product. It's not entirely free, but it doesn't cost $10,000. I've used Altium at work before, and I've been very happy with it. So I'm going to start importing resistors, making symbols, and going to town. Let's see. Library Explorer. I believe there was a supplier link. Well, I have that installed. Huh. So this will let me link this to DigiKey, which should give me an opportunity to bring in all the parts. So this is one of the pieces I've pre-selected. Hi Mark. Yeah, so I've got the schematic software is Circuit Studio. I actually am using a 4x3 monitor. I don't know if I can adjust the stream settings to pick a bit different aspect ratio. Video. I'm just going to leave the aspect ratio alone for now. Let's see, I should be able to search. Okay. I think this part here. Now, yes, this will show as linked through to DigiKey so that when I go to build up my bill of materials, it doesn't show something completely silly. Printing this against DigiKey, it looks like I'm still going to have to put in some of this manually. I'm just going to pull in their description. And this will show up on the schematic for this component, so I'll put 10 megs, say OK. And now I'm going to add a new schematic. It's been too long since I've done this. And there we are. One resistor on one input stage. Next part, so again, I'll start with setting up the supplier links, Drop it down a resistor symbol for this. And then update the description from DigiKey. A full version of Altium has tools that do this a little bit better, but again, I'm not made of money. Yes. The amazing and tedious and boring process of building up your component library from nothing. Oops, that's right, this is an 0.1%, which is why I'm calling it out. I'm using high precision resistors for the input stage so that I don't have to spend extra time doing calibration procedures later. Which means I should go back and update this. I do have a leading space here, and I am the kind of person who cares. This was an 0603. All the fun nuts and bolts of setting up components. I'm sure, Mark, you are just totally thrilled to be watching me do this. Alright, how many more resistors do I have? I think I've got 2 more in this list. Yep. So it's going to be a 1K resistor 1. The nice thing is that I already have these pre-staged, so I know what I'm looking for on DigiKey when I get there. And then it's just a matter of copying and pasting data. Alright, and the last one on this list was this 111 ohm part. Here we go. And this was unfortunately an 0402 because that was the only thing I could find that was a 1% resistor at 111 ohms. Oh yes, DigiKey has 3 entries for this, for the 3 different packaging styles. So that's quantity 10,000 pricing. I can't buy that many, or I don't want to. These two look almost exactly the same. This one, aha. Packaging on this is cut tape. Packaging on this one is a digi-reel, which means they're going to cut it off the reel and repackage it on a new reel, and I don't really need that, so I'm going to go with the cut tape version. Say OK. Once again, it's a resistor. Doo-doo. 111 ohm, 0.1% resistor. And now I can hit my component shortcut and start building up the rest of my resistor divider ladder. So this resistor divider is the first stage of the input to the multimeter. And my input voltage will go in at the top of what's going on here? Okay. The input voltage goes in at very top here, and then I'll have multiple taps off of both sides of this. So here this will be the reference point, and then at each of these points along the ladder I have a tap that lets me choose the right resistor voltage, or choose the right division. So this is basically no division. This has got 10 megs above and 1,100,000 11 and then 11. So it's basically a perfect 10 to 1 divider. So that's 1/10, 100th, 1,000th, divided a couple more times down. And so this will correspond to a 0 to 10 millivolt range to get 10 millivolts on my ADC. The next tap will be divided by 10, so a 100 millivolt input gives me a 10 millivolt output. This will correspond to the 1 volt range, 10 volts, 100 volts, and if I'm feeling really insane, I can try to put 1,000 volts into this ladder and see what I get, and see if I can not blow everything up in the process. More to the point, I wanted more than 100 volts input, and since I have a 4-digit display that I'm going for, and the biggest digit will go up to a 9, unlike a traditional like 4.5 digit multimeter, 3.5 digit multimeter. My maximum count is 10,000, which means I'm either going to go 100 volts and have 2 decimal places, or 1,000 volts and have 1 decimal place. So that's what I get. And I think I'd worked the math out to this, and it came out to a 10 to 1 ratio because it was 11 over 111, rather than if I wanted a, yeah, it's The ratio is slightly funny. It comes out to 11 over 111, or 11 over 111 million. And it does in fact come out to a 10-to-1 ratio, despite being made of factors of 10 parts. And that's where this 111 ohm resistor on the bottom comes in. It's because this is, let's see, where did I put the calculator? So 111 divided by 1100 is almost perfectly 1/10. And that same math scales up as you add decimal places to both of those in the same way. So that was everything I had planned to put up tonight in terms of pre-prepped parts. I think I'm going to go off and search for an input. DigiKey, here we come. And I don't need the rest of these tabs anymore. Goodbye. Looking for relays. So I'm going to use relays to select each of the inputs and not some kind of solid state switch, because at the 100 volt and 1000 volt ranges there will be a voltage difference of about 1000 volts across the two terminals of whatever switching device is on the highest tap. And if that's, well, let's just say a silicon device would have a hard time standing up to that. So I'm going to look for read relays because that seems to be the commonly recommended thing. I like parts that are active and in stock. Let's see. I'm probably either going to have a 3 or a 5 volt drive voltage on this. And I don't need a high contact rating, so I'm not going to pick anything there. But I'm going to see what happens when I pick, let's see, how much is an average relay here? These are about $1. Okay, that's not bad. Let's see what happens if I ask DigiKey for relays that'll switch 1000 volts. They're about $3 and they get expensive fast. I only need the high voltage rating on 1 or 2 of them. The rest, because of that resistor divider, will only be exposed to 100 volts or a little bit more, depending on the exact details of what the input voltage is. These are all of 5 volt drive current, drive voltage. That's makes me a little sad because I was hoping to be able to do this with 3 volts, but I guess I'll have to have a 5 volt supply. Actually, if that's the case, I'll drop the coil voltage and see if there are any better options. Not really. Get some 12 volt parts as well. the difference between the first 5 or 6 of these? Similar prices, not quite all the same, but close. Series is just a manufacturer's nomenclature. Packaging is all sort of moot. Okay, so these are 3 different variations on a coil voltage and current. And these are different. These are all normally open. They all have a rating of 1 amp, which is totally fine. Turn on voltage on these roughly matches their coil voltage. This manufacturer has specified operating and releasing times for their parts, which is handy. These, not so much. This part has a built-in coil suppression diode, presumably. I think that's what that nomenclature means. So I think I want to do a second search for a lower voltage relay. And use that before I pick my actuating voltage. So I think I'd said the remaining positions are more in the 200 volt range. If I'm really lucky, I can find similar relays with the same footprint and not need to change footprints too much as I change relays. It'll also make the layout a little bit easier. These two look similar to this one. I'm going to pull this up as a reference. This one's 5 volt actuating voltage. It has that diode in it. It's a through-hole part. I want to look at the data sheet on this and see. Yeah, so here's pin size and alignments. And then this one, that's 12 volts, it's 5 volts. This looks similar. I want to see if the pin spacing on this is the same. Okay. 0.2, 0.2, and 0.2 inches, and this is 0.2, 0.3, and 0.3. Okay, well, not going to win anything there. This variation also has built-in diode, which would be nice. I'm going to have a quick look through this and make sure that this actually means that this has a built-in surge suppression diode. The contact resistance on these doesn't matter too much. Good night, Mark. But it's nice to see that it's a small value, given that this is only the sense current and not the full current path between positive and negative. The resistance on here will cause basically a negligible voltage drop between this and the ADC input. It's getting late here. Key indicated this one had a diode. I don't see anything about that on the data sheet, except for this option D. Capacitance, shock resistance. Probably won't be washing these anytime soon, but it's nice to know that they're sealed and you can't get junk in them. It's nice to see parts that are REACH and RoHS compliant. No terribly crazy chemicals in there, which is nice. Okay, well, if this manufacturer isn't going to list a coil suppression diode on their datasheet, then I'm not going to pay the extra 15 or 20 cents for that part when compared to another similar component that doesn't list that. Let's compare this relay. This has a data sheet and a spec sheet. Well, that looks like the same in the spec sheet. Okay. What an interesting footprint. It's kind of shaped like a dip, but then they bent the leads out and they've got them in some really unusual positions. Well, it's just numbers to the CAD program. On the plus side, you can't get it installed backwards, which is handy. Bigger. Is there anything really unusual in this data sheet that it calls out? Not really. So these have a significantly lower coil power. They're about half. That directly translates to power and heat and capacity for the power supplies that drive this. So I'm pretty tempted to go with the slightly more expensive relay in this location just to have the lower power consumption. It looks like I'm just gonna deal with having two different types of relays, two different layouts in the two different positions. So let's make a footprint for this one, or a schematic symbol. Alright. What are the chances I have... Nope. My goodness, it's William. Hi, William. Enjoying watching me do circuit design. Okay. I'll add 2 pins here. So I start with the inductor symbol because it matches what's on the symbol already. And then I'll draw in the switch part. And let's see, I want this to show the pin numbers. And then I want to make sure that these match up with what's shown on the data sheet so that when I go and do the footprint for this at some point, I don't make a giant mess of it. So I decided against those. So pins 2 and 3 are on the coil. and pins 1 and 4. So this will be pin 2. This will be pin 3. That's already 4. Alright, and I could split this into 2 symbols and be able to move them separately, but I think for now this is easier to reason about on my schematic, so I'll do that. And now place a new relay there. And with that, I think it's just about bedtime for me. It's getting close to 11:30 here, and it's time to go to bed. So I will shut the stream down for the night and probably pick up whenever I have another free evening.